Well, welcome to this community call. I've put the numbers up here this time, so you can see there's community call number 64 in July. And today we were going to cover many things, but primarily we're going to cover the fact that we did a 1.8 release that came out last week and finish up on some of the topics inside of that that we hadn't previously covered in previous community meetings. So I will give you a little overview of what happened in 1.8. Jeroen will touch on namespace scope data access. Shubham will then cover how we support for loading certificates on Dapr sidecar. And then we'll finish up with Alessandro just looking at some of the service bus components and enhancements. And then finally, John will look at pluggable components, which is an early sneak peek of what's happening in 1.9 release. And then as always, if we have some time at the end, feel free to have some open discussion and bring your questions. So with that, what we want to say more than anything else is that we did a 1.8 release, and thank you to everyone who contributed towards the 1.8 release. And then overwhelming number of contributors that we had. We had a record number of contributors again, over 91 people contributed to this. And importantly, not only the contributors, we had a number of the RCs released out that were tested by lots of different organizations that really helped validate the release. So we could not have done this without everyone's contribution and the involvement of the whole community. And we can't thank you enough for everything that you've done to help this release be the success it is. It was a pretty substantial release. And in this release, you can see if we go and look at the release notes inside here, these are the release notes up on our Dapr blog. You can see release notes are actually on the GitHub repo, but the release contained many things from a feature perspective. Covered data ledger topics, distributed new API we introduced, which was distributed lock API. We introduced several new components. In fact, in total, we introduced 9 new components, including a component that now supports WAS and middleware. The resiliency policies that introduced in 1.7 had defaults, overrides provided them. So now you can override the default policies that get included as part of, for example, with service invocation. Jeroen will touch on the namespace support side of things. We improved Dapr, a metadata API that can return information about component capabilities. We'll dive into the sidecar certification installation usage. And then many things just improve running in Kubernetes in production generally. And one of those things that we presented in a previous release, which actually Alessandro did in our previous one, was about how we now add a watchdog capability for the injector service into the Dapr operator. So if you read through these release notes, there was a ton of stuff in this release. All this stuff is linked to docs. We'd love to, as always, get your feedback around these things. And we feel as this was one of our most substantial releases that we did. And certainly one of the ones that contained many features that we think will be really useful for you as you build on Dapr going forward. So thank you for everything inside this. If you want to go back to the previous community calls, we actually covered the default resilient retries in community call number 61, the dead letter topics and the distributed lock API in community call 62. And then we did the sidecar injection watchdog in the previous one, 63. So I encourage you to go back and look at those previous recordings. A lot of those recordings actually have also been linked into the docs themselves, so you can watch them from there. So thank you once again. And so with that, what we'll do is we'll just move forward now, and we'll actually touch on the final pieces of some of the features that we did in 1.8. And I'll hand it over to you, Jeroen.
All right, thank you. Let me just share my screen. You need to enable me to be able to share my screen.
You can now share your screen.
That is correct. All right, let me know when you can see it.
Yes.
Okay, so today we're going to talk about a new feature in 1.8 called namespace scope data access, and why do we need this and what does this do? So before 1.8, if you had 2 Dapr applications running in 2 separate namespaces, both of them having the exact same Dapr app ID, and for those of you who don't know what the Dapr app ID is, it's basically the identifier of a unique Dapr application within a namespace. And so Dapr does many things with this app ID, like enable service discovery and scoping data access to it. So if you had these two applications, both using the same unique app ID, unique for their namespace in two different namespaces, and they were all writing to the same database, they would basically override the data. So this is how basically Dapr constructs the key inside the key namespace of whatever database you're using. It'll take the app ID and then double pipe it to the actual key that you're saving. So if you're posting state for key one, it would look like this. And so if you have the exact same deployment inside of two different namespaces with the same app ID, they would just override each other and cancel each other out. And this is a problem for many scenarios. One particular scenario that really developers looking at when running Kubernetes is to be able to have specific development environments or feature namespaces, which is pretty common on Kubernetes, or namespace per teams, where you just want to deploy different versions of your app. But as far as your CI/CD pipelines go, you want to continue using the exact same YAMLs. You don't want to start, managing YAML definitions based on the actual namespace that you're running in Kubernetes. And so you actually want to allow different teams or a single team using different features, different versions of your application to run in multiple namespaces, because that's the level of isolation you have either for a development team or for a feature. Now, before 1.8, basically ops teams would need to have the database per namespace, which would be very, very cost effective. For example, especially if the database wasn't inside of Kubernetes. So imagine it's something like Azure Cosmos DB or Google Firebase, where you need to spin up a database per namespace. That's quite costly, both in ops terms and then just costs of data and operations. And then if it's on Kubernetes, then you might need to scale out more than you would, because databases take compute, and of course they take memory. And of course it's quite an operational overhead. But starting 1.8, what you can actually do is configure a metadata value for a state store component. And we've already had this in Dapr called key prefix. So we've had state sharing strategies before, where applications inside of a single namespace could share all of the state from within a particular database, or all databases even. But in 1.8, we've introduced a new one called namespace. And this basically causes the following key construction strategy, where you have the namespace and then the app and then the key, which really allows you to use a single database for all of your operations. Another key scenario, by the way, that I didn't mention for this is sometimes in production, you would have multi-tenant namespaces where each tenant might represent a customer, and you have the exact same code and the exact same CI/CD pipelines, but you want to basically like partition your single database or multiple databases per customer. And so before this feature, that wasn't easily doable. But beginning the 1.8 with state sharing, you can actually share the same state store between multiple tenants, and then have Dapr manage everything for you, where you don't need to change anything in particular in regarding to your naming schemes. Okay, so let's see a small demo of how this is actually done in practice. Before we show VS Code, I have a GKE cluster running here. So this is my GKE cluster 1.22, and it's running Dapr. Let's do Dapr status, it's running Dapr 1.8. So we're all good there. And then I have the Dapr quick start tutorial basically deployed into my default namespace. So I have Redis, which is deployed to my default namespace. And then I have a Python app, which is calling my Node app. And the Node app is actually writing data to the Redis database. So pretty simple. Python calls Node, Node saves data through Dapr into the Redis database here. This is quite simple. And I also have a different version of this application deployed into a test namespace. Currently here, I only have the Node application, and the Node app is configured to write to the same database that's on the default namespace. So we'll deploy the writer in just a second, the Python app that calls the Node app here. And if we're going to VS Code, these are the YAMLs that I'm using. So this is the Redis YAML for the default namespace. You'll see that we don't have a namespace specifically called out here, which means it'll deploy to the default namespace. And then it's just your regular good old Dapr component for Redis. Nothing special here. The Redis component on our other state store actually has the Redis host to point to the same database that's deployed into a Redis cluster. So in this scenario, we have single database for both these applications. And if I go here and I look at the endpoint that I have for my Node app, I can start querying the Node app, and we'll do curl, and we will reach out the order endpoint. And if we hit several of these, you'll see that it retains the order. So it's incrementally raising the value for the ID of the state that's getting saved. So you can see that it's pretty consistent here, which is kind of great for us. Now, what we're going to do is go back here and we'll go to namespace A and deploy the Python app writer. So we're going to deploy Python into namespace A, which is really namespace test here. And we can see that it's up and running. Let's watch it, wait for it to go up. Yep. And now if we curl the same endpoint, which is our Node application on the default namespace, we can see that we are getting different data, right? So it's basically, they're both overriding each other. So what we can do here is go to our Redis components and add our key prefix. And I'm just going to put the value here of the namespace. Then I'm going to go to the other one and copy it into that. And once we have that in place, we can apply the Redis component here and the same YAML definition on the default namespace. And now we can start rolling things out. So we will roll out all of our deployments. So Python app in both of them, and then Node app. I actually don't need to roll out restart the Python app, but it's just a habit. Okay, so everything's currently restarted, and we can wait for the Node app, the latest Node app, to start running. Let's put watch here, and it's running. Cool. And now we can start curling it. So we will curl the same order, and we will hit the endpoint, and we can see that. Ta-da, we have two different applications, two different namespaces using the same database, but they each have their own state, and the order is preserved. And we like order because the universe doesn't have it, apparently. Okay, and that's pretty much it. We are looking at enabling this exact same feature for 1.9 for PubSub. You know, think about how you have the same problem here that's applying also to PubSub components. If you're using a message bus, you don't want to override the consumer groups that you're creating per namespace. And that's pretty much it. So I'm going to stop sharing here and back to you, Mark.
Fantastic. Yes, it turned out to be pretty useful for that. Does anyone have any questions that they want to post in the chat window before we move on from this? All right, well, if not, thank you, Jeroen. And all right, let's move on to our next 1.8 topic, which is support for loading certificates on your Dapr sidecar.
Okay, can you see my screen?
Yes, we can.
Okay, perfect. So yeah, hey all, this has been added with 1.8 as well. And before we move on to the cert installation, there's one feature that is a prerequisite for that. So it gives you context on what's happening. So with this feature, you can install any pod volume. You can mount any pod volume to the Dapr sidecar, which means that using these two new annotations, you can configure any of the volumes supported by Kubernetes. This documentation takes you to all the supported types of volumes. So anything that you see here that can be mounted on your pod can essentially be mounted on the sidecar as well. And there are a couple of use cases. The first use case I can think of is it is documented in this documentation right here. It's the link to this documentation is also in the presentation. You can check later. But yeah, this is an example where you have a local file secret store, and that basically comes from say NFS. So your JSON file, its secrets is in NFS, and you use it in this volume mount. This is one example. You can go through this example and have a look. The other one that we'll talk about today is how to install certificates in Dapr sidecar. So moving forward, for that you need two things essentially. If you're using self-hosted mode, and if Dapr is running as a process, the first part is really straightforward because you just have to install the certificate in your host operating system. But say if you're using containers, then you have two ways. So if you're using Docker and Docker Compose, then maybe you can create a volume mount and mount the certificates to the Dapr sidecar container. If you're using Kubernetes, you can use the mount feature that we discussed earlier and use that to mount the certificates to the Dapr sidecar. Once you have that, you can use this environment variable SSL cert del and basically point this to the certificates. So this is something that you might be familiar with from the Linux world. And in the case of Dapr, we also have support for Windows. So even if you're running Windows containers and you have this environment variable, behind the scene, it takes care of installing the certificates to the root store. And there are like a bunch of use cases. For today's demo, we'll look at the HTTP binding use case. So you can basically use HTTPS now with the HTTP binding by installing the SSL certs on your sidecar container. So I have a recording for that. I didn't want to risk it by showing it now. So we can just watch the recording maybe. And let me know if you can hear the voice.
Hey, in this video, we'll look at...
Is it audible, the voice here?
Yes.
How to invoke...
Okay, perfect. Yeah.
Hey, in this video, we'll look at how to invoke a web service over HTTPS using the HTTP binding from Dapr. There's a new feature from Dapr release 1.8 that allows you to install your own certificate in the Dapr sidecar. So in this demo, we'll install some self-signed certificate in the Dapr sidecar and then use that to invoke the service over HTTPS. So let's jump right into it. So we have a Kubernetes, Azure Kubernetes service instance running with the Dapr control plane already installed. And let's look at how the web server looks like. So it's a pretty simple main.go file that looks for some certificates and it starts a new web server. And this is the simple handler that prints out hello world using HTTPS, and note that this uses the listen and serve tails method. So this is secured. Next, let's look at the Dapr code itself. So we have a simple application here. The only job is to invoke a binding, and once you invoke it, you print a response, sleep for 5 seconds, and then perpetually repeat yourself. And this binding, the hello world binding is located here. Pretty simple binding. It has a URL that says HTTPS, and this is the IP address of my Ubuntu virtual machine that's hosting the web server that we saw earlier. So let's look at this deployment file. So a couple of things going on here. The two most interesting pieces in this example are this. The first one is a volume mount. So if you look at this, it says that a volume called cert volume is mounted in the Dapr sidecar at /dem/certs. So this cert volume itself comes from here. So it's a pod volume that basically uses the Kubernetes secret, and the secret name is HTTPS cert. And in a while we'll look at how we created the secret. But this secret contains a cert.pem file, which is the self-signed certificate that we need to invoke the HTTPS web endpoint. So, and that certificate now becomes available to the sidecar at /dem/cert/cert.pem. So that is one part of it. The second part is this environment variable called SSL cert del. So this environment variable tells the sidecar tells the Dapr sidecar that hey, you can trust all the certificates that are present in this particular folder. And it's a pretty standard thing from the Linux world, but we also have implemented a custom logic for Windows world for this particular environment variable. So yeah, let me show my terminal now, and let's look at a few things. So first of all, this is what we use to create a secret. This cert.pem comes from, again, it's a self-signed certificate that we are using, and this won't work. I think it's already created. So yeah, it already exists. So next what we'll do is let's apply this particular deployment file and see what happens. So there we go, and let's do get pods. So it's starting up and it's ready. So if you look at the logs from here, so I'll do and let's use so this is the application container, and there we go. So it is continuously printing this hello world.
So yeah, there we go. And feel free to look at the resources which has the documentation for these things. Yeah, I'll stop sharing.
Fantastic. So kind of one of the primary scenarios you were showing here was effectively using HTTPS on bindings and loading certificates inside a sidecar. Is there anything else that would be useful for the volume mount?
Yes, actually our WASM middleware component reads WASM modules from file system. So it's actually pretty timely that the volume mount came together with the WASM extension so that it can be used to load the WASM models into the Dapr sidecar.
Oh. That's something else that we should be good to have a demo with sometime in a future call.
Yes, definitely. I mean, we actually do have a community call where Long Day from Intel demoed this a while back, way before it was even a PR.
Oh.
Yeah, so we might be able to find that and just point out in Discord or something, but it would really be good to show it again because there have been some changes in user experience. So yeah, I definitely think we can show it again.
True, that is true. I'll dig that out and I'll put it into the notes when we publish on the channel. Super cool stuff. Thank you. Right, if there aren't any other questions, then let's move on to Alessandra.
Hi, Mark, can you share
I will share my screen.
Please?
Yes, I will share my screen. Hang on, here we go. Can you see this?
Yes. Okay, so just very quickly, wanted to cover a few improvements to our Azure Service Bus components that came in 1.8. And this applies to both the Azure Service Bus queue binding and the Azure Service Bus PubSub broker. Can you go to the next slide, please? Let's start with this. A customer updated Dapr from 1.7 to 1.8. They reported a 10x performance improvement using Service Bus with Dapr. If you have to remember one thing about what I'm talking about today, this is it. Can you please go to the next slide? And last one. Okay, what's new in 1.8, to be a little bit more specific. The Service Bus queue binding has more features to bring it almost on parity with the PubSub component. In particular, now we support concurrent handlers. Before, there was only one handler running at the same time. Now, the default is one, but you can also have multiple messages coming in parallel. That's an option. And we also support locks. Before, if your binding was taking too long to process a message, the message could have been sent back to the queue. So another instance of your application could have received the same message. Now we lock it, so your application can take as much time as it needs to process the message. We also have a few new metadata options that you can read about in the documentation. And these options are essentially named after the same options that you see in the PubSub component. And they allow things like controlling the concurrency and controlling the connection, the reconnection if the connection to Service Bus fails. For PubSub, there's two things that I wanted to highlight. We removed a few metadata options and we added new ones. Some of these changes were technically not backwards compatible, but the improvements, like now the things that we were doing before that required the metadata changes now happen automatically. So things like active messages recovery and prefetch, those are not necessary anymore. The component has been updated, so we can achieve better performance even without using prefetch. And for connection recovery and massive connection attempts, before Service Bus would only try to reconnect up to a certain number of attempts, and then it would just fail and nothing would happen until you restarted the sidecar. Now that has been removed and it keeps reconnecting forever, and you control the minimum and maximum. So if you're using Service Bus and you were depending on those metadata options, if you feel that you need to change them because of your application's requirements, please take a look at the updated documentation and see if you need to make any change. For most users, you will see that just accepting the defaults will give you so much better performance and such a much better experience without anything to do. For both the PubSub component and the binding, you will see much improved performance and much better reliability, especially in the case where the connection to service bus fails or there's some transient failures. Now the components will be much more resilient and will handle failures in an easier way. All of this is in large part thanks to the new SDK. We want to thank the Azure SDK team, of course, for their contribution and for making this possible. Now, I'm going to be very boring. I do not have a demo because there's not much to demo. The experience will be the same that you were using before. But if you were using Azure Service Bus with Dapr, you should definitely upgrade to 1.8. It will be a much better experience as validated by other users. And if you're not using Service Bus and you're using another PubSub broker, maybe you should consider using Azure Service Bus. And that's all for me. And then Paul wanted to share a couple of words in the next slide as well. On to you, Paul.
Okay, thanks. And next slide, please. Maybe it didn't refresh in.
Did you add a slide?
Yes, can you try refreshing the page maybe?
Oh, here.
There we go. Thanks, Mark. All right, so like Alessandro said, the fundamentals of Service Bus are a lot better with the perf and reliability and metadata parity. And we also wanted it to be easier to deploy things like Service Bus and all the infrastructure you need. So what we did is we worked on a new integration with a tool called the Azure Dev CLI. So if you're targeting Azure, we now include in a new set of repos, a set of the infrastructure files you need, like the infrastructure as code for Azure. And that will take care of provisioning Azure Container Apps, Service Bus, and a few of the other resources you need to make monitoring really sing. So now that this tool is actually being released today, it's called AZD or Azure Dev CLI. So in that repo or in a code space, you can simply say AZD up, and the process of provisioning and deploying will happen in that step. And for those of you who are using, CI/CD and more sophisticated rigs, there's more discrete commands for things like AZD provision, AZD deploy, and so forth. So please check it out. It's a great way to try Service Bus and Azure Container Apps. And we released in 3 languages so far. And if you all like it, we can do more. So Python, JavaScript, and C#. Thanks.
All right, so you can visit that URL down there, yes, to get this.
Yes, that's a great way. And that URL is just a tag, but it has the 3 templates now. And as we add more, like I'd like to do, bindings, and I'd like to put state stores in there. So I think that list will grow over time.
All right, this is fantastic. So this is a great update across the components, across Dapr. There's a continued, Alessandro, there's a continued push to improve all the component stability as a whole, yes? Not just ones, but across all the other components, correct?
Of course. And but for Service Bus, there's something else that we are looking into. I'm not going to say it out loud yet because it hasn't been committed, but we have some other updates there. And then in general, we are working on improving components, the Azure ones, but also not the Azure ones, also the ones that are generic.
All right, fantastic. All right, so with that, that concludes sort of our 1.8 overview. As you can see, there was tons and tons of features inside it all. I encourage you to go back and look at all the other previous videos. And what we'll do now is we will do a sneak peek coming soon of features coming up in 1.9 release, which is pluggable components. So John, I will hand over to you.
All right, thanks, Mark. Let me share my screen. All right, can you guys see it all right?
Yes.
Okay, cool. Yeah, so as Mark said, one of the upcoming features that's going to be in preview in 1.9 is going to be pluggable components. And this is the idea that rather than compiling components directly into Dapr, you can build components outside of Dapr in any language that you want, and then communicate with them via gRPC to provide functionality such as PubSub, state store, et cetera, using a custom written component. So those people who maintain forks or other things in order to keep custom components built would be able to move those outside of that build process and no longer have to maintain a fork, for example. So how does it work? At a high level, basically you define a new pluggable component. So I'll show you an example in a little bit here where I've written a .NET Redis state store. So you define the component, then just like normal, you define an instance of that particular component. Inside of Dapr, there are stubs for each of the building blocks that implement those API calls over gRPC. And then the pluggable component operates as a daemon, and then the Dapr daemon connects to that pluggable component externally and then does the work. So effectively, instead of just calling, Go functions, it calls them over gRPC to a separate process. So this is just kind of a visual example of what I was referring to. So inside of the runtime, we've got stubs. Right now I have, half of them. By the time we release, all of them will be there. So pub sub, state store, right? And so you could, for example, have a Redis state store written in Ruby if you wanted, or, a Cosmos DB one written in Java, whatever happens to make sense, as long as the gRPC libraries exist for that language. So again, there's a new resource called pluggable component, describes the type. So, these are all least surprise, right? So state, pub sub, etc. You give it a name, and then you also define how to either run or find the component. So you can give currently like a container image and a version, or if you have the daemon already running, you can provide a path to an existing domain socket. In standalone mode, currently, when you have a container defined, it will run a new instance of that container in Docker and then map the domain socket. So inside of the config, nothing too surprising. This new notion of a pluggable component has a name, right? So you give it a particular name, and then inside of the spec, you describe the type, the version, how to find it, etc. And then on the right-hand side, you have your traditional component definition. You'll notice now that we have a new state store called .NET Redis, which is a combination of the type and the name from the pluggable component. And from a user perspective, it behaves exactly the same, right? There's no extra configuration required. As long as you can connect, run the container image or connect to the socket, you can now use this new component type just as you would use any other one built in. In the case of the container, again, what happens is that the Dapr daemon starts the container, creates a shared volume, then injects an environment variable so that the two know it's a well-known domain socket. And then the component process opens that Unix domain socket, and then the Dapr daemon connects to that domain socket and then performs the operations. So this is just like a visual diagram for people who are more visual. So create a socket name, start a container, open the socket, and then the Dapr daemon connects back. So the cool thing is this actually provides this extended functionality with very minimal overhead. So again, there will be more performance testing as time goes on, but very quickly I put together a .NET gRPC component, and then I benchmarked it against the built-in component using the same machine, same systems, et cetera, and simulated at the peak about 800 users per second, bursting up to about 1600 users per second. You'll notice there's slightly elevated response time, but comparatively, very little in terms of overhead. So I'm going to go ahead and show a quick demo. This is pre-recorded. I will pause and narrate a little bit as it goes. Basically, I will show Dapr, shockingly, and then I will show a Golang in-memory state store that's in a container, and then a .NET Redis state store that has been started manually. So here, I'm going to go ahead and I'm going to start manually the .NET Redis state store. So it's going to boot up. And then I'm going to go ahead and start the Dapr daemon down below. And we'll notice, oh, sorry, it went right back to the beginning. You'll notice that as Dapr starts up, it's going to pause for a few seconds. That is currently, for testing. But you'll notice up top, it started a Dapr memory store as a container, right? So once it's finished initializing, you'll notice that I've gone and deleted all of the keys in the upper right hand from Redis. And then at the very bottom, there's a set of curl commands that taken from the the examples that we have that post data to the pluggable state store and then to the user state store. So then I read back the memory down here from the in-memory state store, which is the one running inside of the container. You'll notice that we wrote the Bruce Wayne, we got it back. And then you'll notice that we also posted, Alfred to the .NET state store. And then up in the upper right-hand corner with the Redis CLI listed the keys, shows that, the key was created. So the really neat thing is that depending on, your languages, whatever else, you can very easily implement a pluggable component using your language of choice. And the goal is to provide, at least initially, SDKs for a handful of languages at the very beginning so that you can build new pluggable components very quickly. For example, the .NET SDK that I've put together for writing a pluggable component, the actual implementation of the Redis state store is like 43 lines of code, most of which are curly brackets and method definitions, not actual logic. The logic is actually very short. So, being able to do this definitely extends people's ability. And so I'm looking forward to, getting feedback on not only the functionality, but also on what kind of cool things people are building, as extended components for Dapr. So that's all I've got. Thanks. Back to you, Mark.
That's super cool in terms of being able to offer an ability for all sorts of developers to build different types of components now. Do you see all the existing components being converted this way, or only a partial number of them?
I mean, we certainly could. I think the biggest value that I see for many people is the reduced surface area. The number of dependencies that you have when we're building all of them into the Dapr daemon, right, is quite high. So I think that for a lot of people, being able to minimize that both for security reasons and also just exposure to various types of code is certainly good. I think the critical thing will be making sure that the performance is as close as possible before we seriously consider that. But I definitely think it's an option. I think that would be a really neat way to sort of make all those components, I guess, progress in their own way, as opposed to like as a giant monolith, right?
And from the sorry, go ahead.
Yeah, no, I agree. I think this is a really good feature. The main thing it's going to enable is, like John said, private forks of Dapr are going to become so much easier to manage. And in many cases, just you won't have to manage a fork anymore, which is great. John, did you update the issue on the Dapr repository with the pluggable components here and the whole user experience side of things? Because I'm not sure we have that. And like we need to vet the design as maintainers before we can allow the PR to be merged. So as soon as it's out, the sooner it's out there, the better it will be. And allow us to really, merge it into 1.9.
Yeah, that's on my list for this week. Now that I'm back, is to update the whole thread.
Yeah. So it's great to see you have a POC, but usually we'll start design first. But this is really great. I have a question about the container section in the pluggable components already. Is that based on a Kubernetes container pod spec?
The container part, no, it's just part of like the pluggable component spec itself.
Right. So like, for example, users that are running it on Kubernetes expecting things like private container credentials. What's the solution for that if you want to basically?
Yeah. So in that case, like we haven't gotten to the Kubernetes injection part, but to treat it like a sidecar, just the same way that we would inject other things. So to use the built-in Kubernetes, container secrets and registries and everything else, just as you would expect.
Yeah, but like the Kubernetes container spec has like special fields and properties to be able to express private credentials, for example, if you want to, and like a host of other properties, right? Like things that people who are running containers on Kubernetes would expect as a Kubernetes native platform. They would probably expect to see the same container spec on the pluggable component. And so this is something we need to look at. I think we can solve this, but this is why I'm saying let's flesh out the design on the GitHub issue as early as possible so that we can address all of these questions that are necessarily going to come from at least the Kubernetes user crowd.
Yeah, no, it makes sense.
All right, thank you.
Yeah.
Yeah, and then 1.9, the SDK use is not going to be required, right, John?
No, so the SDK is just their convenience things. And you could implement the gRPC service yourself, but to get people up and running as quickly as possible, in this case, the .NET SDK is based on ASP.NET with the gRPC services. And basically all you have to do is write the implementation of the interface and then call a method, to register your implementation. So you don't have to write all that boilerplate code to, write a gRPC service. That's really all the SDK does, is provide a framework and some boilerplate code.
Yeah.
Yeah, that makes sense.
Yeah, and Arthur, to touch on that point, so the earlier POC or design that was driven by Patrick Huber, I think, he looked at using the HashiCorp plugin component, because it pretty much streamlines the entire gRPC server lifecycle for the user, so that the actual contributor doesn't really have to think about, recovering from failure, starting the gRPC server and all of that. And I'm guessing this is what you mean for the specialized SDKs to do. And my question is, have you looked at the HashiCorp plugin? Because, it's used in production in almost all of HashiCorp's products, especially Nomad to facilitate these Nomad plugins that they have been running at scale. And that basically removes all of the boilerplate and lifecycle management that you would need to do for a custom gRPC server.
Yeah, so the primary challenge, yes, that is an option and can be used as part of this. I've also used it as well. The downside is that requires that you package everything that you would use into the Dapr sidecar, which is not necessarily a problem. That's totally a way that, again, right now it supports running a container for packaging purposes, or you can define, instead of a container, a Unix socket. But a third option can be provide a path to a binary, and then we manage it using the HashiCorp plugin as well.
Yeah, I'm asking because, now we have like the volume mount support. So, from a Kubernetes standpoint, and also non-Kubernetes, you have like this story, right, where Dapr supports custom mounts, and then you deploy WASM modules on top of it, or, Dapr pluggable components on top of the file system. And then you basically just configure the single Unix domain socket that points there. And you have like a very consistent story, really, where you don't have to deal, with like container image pools, and then, how the surface area of the container specs looks like, and security, which is probably going to be an issue. And all of that stuff. So again, we might need to take this offline, but it'd really be good if, again, I'm repeating myself, but if we put all of these details on the GitHub issue, and then we can have a list of trade-offs between the different approaches and really drive consensus towards, one or two.
Yeah. I think the goal for this this approach we're having now, and I talked to John about that, was not to re-implement Kubernetes functionality. So Kubernetes already handles containers in pods for a reason. So us having multiple processes in a single container would probably end up us implementing the same functionality and lifecycle management that Kubernetes does. So having container as a packaging solution was actually something that I agree to for the POC. But I agree that it's something that has to be agreed upon among maintainers. But I'm personally on board with this strategy over going with HashiCorp plugin for lifecycle management.
Yeah, no, I don't think we'll necessarily have a problem with supporting like external containers. It's just that we need to be really careful about the surface area that we expose for the API specification. And make sure that it's not like a really bad subset of what's existing today, or I should say limited, not bad. And also on the HashiCorp side, it's more about enabling developers to really focus on, like, again, the business logic itself and not all of the gRPC boilerplate stuff. So, we might support multiple paths, one, but it really starts with repeating myself a third time here. Let's lay out all of the issues and then drive these to conclusion. But I don't necessarily see a problem like with external containers. We just need to make sure that all of the details are flashed out, or as many as we can.
one thing I was asking John, and maybe and I can reiterate here, is that I don't think that the SDK or HashiCorp solution for writing the components should be in scope for 1.9, because I think that is a separate design decision than necessarily be able to have the pluggable components implemented. So even if customers and users will need to use write their own gRPC service today, I think that is a better solution in 1.9 than waiting for a full-fledged decision on how to package how to implement the pluggable component in a easy way.
I mean,
I agree with there. Like 100%, I agree.
Even with the HashiCorp gRPC plugin, you still, if you write a Python one, you still have to write the boilerplate gRPC service stuff, right? The only part that the HashiCorp plugin really handles in those cases is spawning the process and then doing a secret handshake and a few other things. So I certainly agree. Yes, like I will post all this information and we can have a conversation about it. But the primary benefit, I think, to the containers part is that, to Mark's earlier question about vending existing plugins, right? It means that if I want to use a particular component that someone has written, I simply have to add the container to it, right? I don't have to install the right version of Java or the right version of Python, right? And so I think that packaging mechanism for the plethora of components that, and their languages that may begin to show up is definitely an advantage. So
yeah, I agree completely. And like, you don't have to convince me about the benefits of containers. I love them. But if we're looking also at edge scenarios, right? Resource constrained environments or environments that can't run container runtimes, for example, it's just also important to make sure that we can load pluggable components from just a file system path or a binary, and that we have a good experience for that to enable these edge scenarios also.
Yeah, I totally agree. And I think that adding a third option, that in that case, actually the Unix socket mostly covers that, because you would just run the process with a pre-configured socket, and that's
all it makes sense.
So
cool, awesome, thank you.
Any other questions that people want to post in the window, or feel free to unmute yourself?
I have a question, maybe to Yaron, but maybe the broad audience can also participate. How do we feel about our current solution for placement service for actors? We are, I'm asking that because we collected feedback about some issues running that in production in large scale. I was wondering, is that something that we was planning on changing, or is this about fixing what we have? Any opinions about placement table and dissemination solution we have today?
I think for the most part, it's been running fine for many users. As we find more issues, we need to fix them. Whatever issues come up, we can fix those. That's my opinion currently.
Okay. Yeah, I think
like for example, if a longer term we wanted to replace Raft, I would be down with that in a heartbeat. I was kind of against adopting it in the early days, but I still don't think it's the best solution for the issue of like maintaining state between the different members.
Yeah, so that is one thing too. One thing that I think we have to invest and then is to have more test scenarios for large scale deployments and see how actors work in those environments, and then specifically about stopping and restarting the cluster or doing a rolling restart, something that caused this big disruption in the membership table. I think that is something that we need to invest in 1.9, and that might uncover some other problems. So that's definitely an area that I want to invest in 1.9.
Yeah, I think extending the test cases for large-scale actor deployments is certainly something important that we can invest time in. We need to invest time in, not can. I'll be more accurate.
Yeah, because all of our tests are about our relatively small clusters, right? It's about small setup. We don't have anything major in size, and then major, of course, objective here. But we try to. I think we have to have some kind of stress test environment where we can
I think you're spot on. And in large environment, like the problem with actors specifically is that unlike any of the other building blocks, they are really sensitive to like things breaking down and restarting, right? So there's solutions like Litmus, which can introduce chaos engineering into Kubernetes clusters that we can use to basically simulate failures and see how things behave. So things like network congestion or pod restarts or Kubernetes cluster upgrades and things like that. So we can use that. It's a SynSIF project, I think, that we can really use to try to imitate a very unstable environment and then see how actors behave, and introduce that as part of our tests.
Yeah, I agree with that. Okay, thank you.
Cool.
And then of course, like if we end up challenging the current implementation, we always can replace. But yes.
Yep.
Okay. Well, with that, then, if there are no more questions, I'm going to stop sharing. And thank you for joining us in this community call.
Thank you.
Thank you for all the presenters today. Thank you once again to all the contributors for the 1.9 release. It was an incredible release. We can't thank you enough. And we look forward to you contributing and getting involved and helping us on the 1.9 release and all our future releases. So please kind of give us all your feedback. And please, if you have any further questions outside of this, jump onto our Discord channel, which is the best place to engage with the rest of the community and ask questions.
All right. Thanks, everyone. Great community call.
Thanks, everybody.
Bye.
Bye.